Dear Dr. Padma, I would like to submit my examination result about create an IoT-based embedded system using the ESP32 to connect data of two temperature sensors. The requirement is create an IoT-based embedded system using the ESP32 to measure the temperature and humidity of a room. Follow the system detail below. One is using single I/O as the MQTT broker. Two, use two DHT00. Just I have the DHT11 sensors connected to one ESP32 as the publisher. Three is use one LED connected to one ESP32 as the subscriber. Four is write a CHR program in the Arduino IDE. Five is upload the program to the ESP32. The sixth is create a dashboard with the following specifications. Is the temperature, use donut chart. Sure. The humidity, use tachometer with a range of 0 to 100. The LED use one or off state. Sure. First, I will introduce the ESP32. ESP32 is a sensor of low-cost, low-power system on a chip microcontrollers with integrated Wi-Fi and dual-model Bluetooth. In this exam, we will use this pin. This pin is the positive equivalent. This pin is ground, and we can use this pin GPIO15 and this pin GPIO4. The GPIO15 and the GPIO4 connect the sensor data pins, each one. And the DHT22 is a basic low-cost digital sensor used to measure temperature and humidity. It's commonly used in electronics projects, particularly with microcontrollers like Arduino. The DHT11 sensor consists of a competitive humidity sensor and a thermistor to measure the surrounding air and outputs a digital signal on the data pin. Often used into weather stations, environmental monitoring system, and other DIY electronics projects where monitoring of temperature and humidity is required. There is a 10K register from data pin to power pin of the sensor. Next, I will introduce the single I/O. Single I/O is a tool to create connected projects. It allows you in a fast and easy way collect as many devices as you need. It's a cloud IoT platform, not code needed. Handle any device from a single platform. Collect all the data and unify the metrics. No matter what or how many devices you have, it just works. Turn data into insights, collect and store your data into the platform, and create dashboards with custom or built-in widgets. Share dashboards with your customers. Okay, this is the experience. Next, I will explain the program of Arduino. In Arduino, I will write this program like this. For the row 1, it means define the single serial debug. This line is a processor directive that defines a single serial debug. This macro enables debugging via the serial monitor that from the single library, which are helpful for troubleshooting. For the row 2, this includes the single label for ESP32 that connecting to single for an IoT platform. For the row 3, this includes the DHT sensor library, which is used for reading temperature and humidity from DHT11 sensors. For the 5 to the 9 row, these lines define constants for the single. The username is this. The device ID and the device ID and the device coordinates as same. Exam once first. The SID and the password of Wi-Fi. This defines in order to connect the ESP32 to the single platform and the Wi-Fi network. For the row 11, it means creates an instance of the single ESP32 class, which managing the connecting to the single platform using the provide connections like username. device ID, device partitioner. Because there have two DHT11 sensors. So in the row 14 and 15, I have defined the DHT1. Number one, the first pins is 4. Connect the these 4 pin on the ESP32 board and defined the second DHT11 pins is 15 on the ESP32 board. This defined the DHT type. The sensor type is DHT11 because my sensor is DHT11, not DHT2. And for this, I can set the DHT1 sensor is pin 1 type, DHT2 is pin 2, and the same type. The P1, P2, I have defined this. In the word setup, serial begin, the byte is 115200, and set the pin mode is 14 on the ESP32 board. For the output pin, the pin is defined for the LED. Control the LED lights turn on or off. The Wi-Fi and ID Wi-Fi. The SSID and the password. Next, this before the program. And set the DHT1 and DHT2 begin working. For the row 33, it means the single resource LED to collect the GPIO 14 pin of the ESP32 like this. And before set. This pin allows remote control. Allow remote control for single I/O. In this same temperature 1, same temperature 2, same humidity 1, and same humidity 2. Like this setup resource on the single platform to read temperature for to T1 and T2. Read the humidity to H1 and H2. The 21, 22, H1, H2 defined output. Output is the data. For this serial print, and this, it means define how to print the sensor values to the serial monitor, like this in the Arduino. In the single I/O platform, we don't need this program. We can delete this like this. This lines just in Arduino output. We can see there have the line same core endpoint, temperature bucket, and the temperature 2, humidity 1, humidity 2 bucket. This are same. These are same. This mean that is used to call a specific endpoint, specific endpoint defined on the single platform. The data is the temperature, like the temperature or humidity. The data is temperature or humidity value read from two DHT11 sensors. This for the first sensor, this for the second sensor, this from the first sensor, this for the second sensor. The data of the two DHT11 sensors can be stored and processed on the single platform. In the bucket, we can show the bucket and record the data about 1 second, 2, 10 seconds, and 1 minute, and so on. And we can output the data record for the IoT AA for some figures. In the word loop, just the name thing handler. The thing handler means that it can be to keep the single collection alive and handle any incoming commands or data requests. Okay, this or the program introduction. Next, we can choose the board ESP32 and the command is com3. Okay, it's correct. We can upload that. Wait a moment. If value and check the program. It's okay, it's right. We will connect the Wi-Fi. Okay, connect the Wi-Fi. Okay, okay, done uploading. We can click the serial monitor. Hmm? We can wait a moment for the show. Just this, we can use the the single I/O platform to create the system, the control system. For this, the data should become more and more. We can see the detail shows like this. No, we can see the detail show is have many errors because we can't create the system on the single I/O platform. Okay, let me create an IoT based embedded system on I/O a single I/O platform. First, we can say I have submit my username like this, and for the device, we can create a device. The device ID, we can set the same as the audio audio board, and copy and post. Okay, like this, we can refresh and okay, online. We can connect the API. We can see this 5 title. One is home duty 1, home duty 2, LED, it can turn on and turn off. Temperature 1 and the temperature 2. We can say the number are different. We can change the LED turn on or turn off like this. Now it's turn off, is off. We can turn on, yes, and turn off, okay. This is the API. For the dashboard, we can create a dashboard. The name is same, okay, 80, and the show empty. We can click this and add white gate. The title is like this, temperature. Temperature 1. We can change the color is red. And the type we can select because the requirement is the dollar chart. Okay. We can select data source, click from device resource, and click the exam the first, and show the temperature 1. The model, we can select the sampling interval. We can set 5 seconds. The display options, we can set the degree centigrade. It's okay. Like this. And we can create the same again. The temperature 2. Select the color is blue. Typo the same, and from device resource, exam first. Next, click the temperature 2. The model is symbol 5 seconds. Display action. Yes. Okay, we can say that have the degree centigrade, and we can create the LED switch. We can change the color is like this, and one or on off state device resource LED. Okay, and add weight again. The title is humidity 1. We can change right. For this, the tachometer like this again. For research, yes. Change, click the humidity 1. Snapping interval 5 seconds. And this unit, we can create the percent. The range value from 0 to 100 will not change. Okay, and save. We can go this here. Like this, it shows the percent. And we can edit the same. Humidity 2. Blue. And the tachometer from the device resource clicked the humidity 2. Sleeping interval 5 seconds. Display options. Create a percent. The range is 0 to 100 or 100. Okay, save. Like this. Okay. For this system, we can remote control the LED is on or off. Now it's off. We can turn on and off. Okay. On, off. On and off. Okay. For the first temperature, we can use my finger touch the sensor. For this, we can change the collect the data for the 1 second. My finger touches the sensor. We can see the number is green. Green. And the home duty follow green. And I can touch the sensor, the second sensor. I can change the time for the 1 second. And like this, we can see the number is green. Okay, like this. Okay, these are all introduction and the operation of my examination record. For the examination record. Thank you, sir. Sorry, sir. There have the next show for the Arduino, because just now the data is have many errors, because we not need not create the system control system on the single I/O platform. Now we have created the system. We can see the Arduino. We can see the temperature 1, 2, like this. Temperature and humidity 1, 2. They show so fast. Okay, this whole of my introduction and operation. Thank you.